Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Telerik. Create compelling app experiences across any screen with the Telerik platform. Telerik's end-to-end platform uniquely combines industry-leading UI tools with cloud services to simplify the entire app development cycle. Telerik offers everything .NET developers need to build quality apps faster. Try it free at telerik.com/platform. That's telerik.com/platform.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 531. In this episode, Scott talks with Gina Marie Maini about functional programming with OCaml.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Gina Marie Maini, who is a functional programmer. Not just a functional programmer, probably the most passionate functional programmer I have ever met. I met you at OzCon, and you were overflowing with functional programming.
I think that's a common narrative of anyone who does functional programming for any non-trivial amount of time, is that you just have to share the love.
Really? I mean, maybe I've been doing it wrong for the last 20 years. I mean, you were like, have you heard the news? Have you accepted OCaml as your personal programming language?
I'm very evangelical. Let's put it that way. I'm a born again OCamler. I did JavaScript development for probably too long, which I guess was 3 years or whatever. Just felt like things were too hard. I couldn't reason about all the state in my program. I couldn't know where bugs would be. I wrote unit tests. Unit tests didn't do anything good. And I just decided one day that I was going to do something different, and saw someone using OCaml and decided this looked reasonable. This looked like something I could do. And I had tried, Haskell, I think, is probably the most common Hacker News trendy functional language. I tried Haskell and kind of felt like I was missing a punchline, maybe. I mean, it seemed a little bit too hard. It seemed like for someone who didn't have a computer science background, all of these higher kinded types, monads galore, I was really, really lost. So OCaml was a really good balance of pragmatism, and really beautiful abstraction. So I guess it's a pragmatic language.
Do you some people say that they look for the programming language of their soul, and, they find it and it's just like, this is what I'm supposed to be programming in. Do you think you came pre-wired this way? Did you come out immediately wired for OCaml and didn't know it? Or did you wire yourself into OCaml?
I think people who have, that's a good question. I hadn't heard that before, but I like that metaphor of your soul being, I don't know. I think if I was a programming language, I don't know, maybe I would be like COBOL or something, imperative and I don't know, closeted in some way. I don't know, but OCaml seems unlike myself. It's a better self, it's,
OCaml lets you be your best self.
Yeah, maybe that's what it is. It does everything I could ever want it to do. It's got it's multi-paradigm. It compiles to bytecode. It compiles to native code. It plays nice with C. People even have it running on ARM. It's all over the place. And somehow, it's like an academic language, but, it favors performance and, as I've said repeatedly, pragmatism. So it's unlike myself. I would say that I am not like OCaml.
So tell me if this is right and walk me through this. For people who are maybe can say functional programming but don't really know what it is it true that if you take something like C or C# or Java and you have a problem that you want to solve, it's basically, okay, computer, here are the things you need to do, in order to get the answer for a problem. But with your functional programming language, it's just more like, kind of like, what is the essence of the problem mathematically? And you figure it out, computer.
Yeah, that's a good, I mean, I don't know what the official definition of functional programming is.
I'm only interested in yours because I want the practitioner's perspective.
Just as a user, I've read, I think I did functional JavaScript all in J. I've read all these, functional JavaScript books. But now that I work in a functional language, I guess I have some more, how can I say this, zealous opinions. I suppose functional programming is thinking of data transformation. I guess that would be, I just think about my programs differently, almost like, it's very declarative. It's what you just said, Scott. It's like you think about what should this do at a high level. I often find myself thinking about, before I start writing a program, what do I want this to do? At the end of the day, what am I talking about? And whatever I'm talking about, those just become types. And then I just transform things and values, some data. And that's basically what my program ends up being, which sounds like I don't even know what I just said, but that's sort of what happens. It's very different than do this, manipulate this. And then you almost find your eye kind of going back up in your program to manipulate some previous thing. OCaml programs don't look like that. They're a flow. They really are just, here's the world, here's what happens in this world, and then this is the result. And that's, I don't know, it tends to mirror human thought a little bit better, I think, functional programming.
Right. You're building kind of a pipeline as you move shapes and structures and data structures from one form to another without concern for state and state changing randomly, because it can't.
Yeah, exactly. State doesn't change randomly. Although, OCaml is different than Haskell in the way that it doesn't necessarily track state. So, for example, you could write a function, and in the middle of it, throw a print statement in there. And, that won't be nothing. That's fine. That's, you can do that. Which again, is a more pragmatic approach, because, I enjoy being able to put a random print statement in my life. But, I don't have.
I would be shocked if I would, who would be against that? That seems like a very non-controversial thing to want to do.
Well, but you're printing to the outside world. I mean, that's a trivial example, but, you could do any sort of side effect, in the middle of your function that takes an int and returns an int. And, the type system wouldn't know any better. I mean, in terms of the signature of the function, it's unchanged. So that's a little bit different. You couldn't quite do that in Haskell. So it isn't exactly, I mean, you still have to wear your conscious programmer hat, but at the cost of, I don't know, it's convenient. So far, I haven't really been burned badly with that, but, I suppose one could be.
So one of the things that makes things like OCaml and functional programming languages like OCaml safer, and correct me if I'm wrong because I'm just learning here, is it because it's a pass-by-value functional programming language?
Pass-by-value, I don't really know what that means.
As opposed to pass-by-reference. I can't give you a reference to an integer and have you mess with it.
Actually, you can in OCaml. So there's actually a keyword. Well, it's not a keyword. It's actually just a function called ref, which makes something that has a mutable value to it. So you could say, you could have a counter that is mutable. So OCaml, again, another trade-off here. Anytime you want to make a mutable data structure or something mutable, you can explicitly with a keyword. So it's kind of like, okay, you're the boss. If you want to make this mutable, that's great. We're just going to represent this in the type system, and we're going to know about it. So actually, it's like when there is a bug, you know exactly where to look, that sort of thing.
I was going to ask you, wait a second, I thought we were talking about the magic of not having state and side effects, and here you just said, well, there's a, don't eat pork, but if you do, here are some great recipes.
Well, look, I think, sometimes an imperative solution makes sense. So OCaml has for loops, it has while loops, it has mutable stuff. You can have, variable length arrays, I think. You can have these mutable things. It's just you got to wear your big kid hat and know when to use them. So sometimes a for loop is a good solution. There's, no one's, you don't have to use, some sort of recursive, looping through a list, for everything. Sometimes you want a sorting algorithm that's going to mutate what you give it. But I rarely reach for those things. It's interesting. OCaml also has an object system that's very great. I never use it. And actually, it's funny. There was a Stack Overflow question the other day about when should I use, object-oriented stuff in OCaml? And the answer was, well, it's never really worth it. And I think that's funny. It's like, the added complexity of objects just isn't worth it. And that seems to be the viewpoint I've seen mainly in my limited time in the OCaml community. But yeah, people do use objects. But again, rarely reach for them. Same thing with mutability. I mean, it's there, but you rarely reach for it.
Interesting. Because what I'm trying to get a sense of is that every language has its own, you talk about religion or picking religion and how you're very enthusiastic evangelist of this thing. How intense of a religion is it? You know what I mean? Like, is it thou shalt not use objects? Well, here's some objects you can use them, but you probably shouldn't. You know what I mean? It
is a bit, that is kind of a paradox, right? Because it's like functional programming is life, but also here's some objects. But I guess, the thing is they represent objects in a coherent way in the type system. I think they do a pretty good job of that. But really the only religious, I would say, quality of OCaml is all hail the ML type system, all hail pragmatism, and all hail performance. OCaml, has, because of just how great the type inference is and how sound the type system is, you can do all of these static checks. And then basically for performance, you erase most of the type stuff at runtime. So you get really blazing fast performance, with a really sound type system. And that's pretty great. And it's also, it's like a great general purpose language. So like for pretty much anything you could ever want to do, whether it's systems coding, whether, I was talking to our mutual friend Rachel at Jet, and they use F#, which is, a basic copy of OCaml. And, they use F# for various endpoints for, just like funneling glue in between different services. So you can use it for anything, and it pretty much works great. So yeah, it's, you can use mutability, you can use objects, all that stuff. And I will say, whenever I have a bug, I always know where to look.
Okay. So you threw, when people talk about the subjects that they're really familiar with, they throw out acronyms and terms that people aren't necessarily familiar with. So you just threw out you said all hail the ML type system. And ML was a functional programming language that's as old as I am, that Robin Milner made in the 70s. What is the ML type system? What does that mean to OCaml?
ML type system to OCaml means, that's a good question. The Henry Milner algorithm for type stuff. I know nothing about type theory, but we have like higher kinded types. So we have, let's see. When I met you at the conference, I went to a Type Theory 101 class, right? So they were talking about, stuff I had heard before, monads, monoids, and functors, right? I mean, all that stuff. So OCaml has functors.
That sounds very mathy. This is the kind of thing where people say the lambda calculus casually over lunch.
Yeah, it's like modules parameterized over modules. So, so functors are something I literally never use, but they're there. And there's actually great ways to use them. The unikernel project I work on uses functors galore. There's even a library called Functoria to make your functors better. So it's just turtles all the way down, so yeah, we have all these, there's even polymorphic types, which are types where, you don't necessarily have to specify what type they will be. And as the program goes along, you can sort of add to that type, with different types. It gives you sort of a dynamic typing type of thing. So there's open types and all these different types of, types that allow you to do dynamic-ish type things. But basically what that means on a day-to-day basis for me is that when I write a function that takes something and uses another function, like for example, let's say I wanted to make my, Gina sum. That's like, let's say, let Gina sum take I and J, right? And then I'm going to I plus J. There's only one thing that these I and J could ever be, and that's an integer. Why? Because I'm using a plus. So it's going to only unify with one type. And that unification is done by some very fancy type thing that I really know nothing about, nor do I really need to know anything about it. So
that's some kind of type inference that is happening, and it's like, okay, I see the two ints going in, there's an int coming out, and that's the end of it.
Exactly. And this can be kind of a hurdle for people who are just starting, I think, because, if you're coming from something like Ruby or Python or JavaScript, you might not realize what it means to have a fully coherent constraint system. So, for example, you might be using a variable in a certain way and sort of a more dynamic style, and then unaware that, you've actually created a pretty incomplete system. It saves you from bugs, for sure, but in the beginning, you might be like, why can't I just do this? Why is it yelling at me? Why am I getting these warnings from the compiler? Why is it not, I don't know, why isn't it giving me the head on this list? Well, you have a nested list and you didn't realize it, or you used it in a way where this function was expecting a string, but you gave it a list. And even though it might have worked in something like Python, it won't work in OCaml because the type system makes sure that everything is formally correct. OCaml was made for formal verification.
This episode of Hansel Minutes is brought to you by Braintree Payments. By next year, maybe even next week, there could be a whole new way to pay. Maybe it'll be the next Bitcoin or the next Apple Pay, maybe even both. Fortunately, Braintree's full-stack payment platform is easily adaptable to whatever the future holds, so you can adapt easily too. You can accept everything from pounds to PayPal to that next big innovation from any device with one integration. And when that new payment method comes out, all you have to do is update a few lines of code. No late nights, no complicated recoding, no stress about staying ahead of the curve. Braintree Payments is here to help. You can learn more at braintreepayments.com/Hanselman. That's braintreepayments.com/Hanselman. The SDK is available in lots of languages, including .NET, Node, Java, Perl, and Python and Ruby. Check it out. So backing up and kind of paraphrasing, so this type system, the ML type system or the Hindley-Miller type system was this kind of classical system that was discovered and then described, and someone got a PhD over it. And then you can make like monotypes and polytypes and free types and do all this kind of stuff. But OCaml has this static type system and then also does inference and gives you less rope with which to hang yourself. So while in other languages you can cast a string to an int and let the grenade start flying, you're more constrained in a language like this because it has to be correct. Is that fair to say?
Totally fair to say, but one addendum, even though it is statically typed, it's not the same. Some people listening might be thinking, oh, like Java. Not like Java in the sense that you have to explicitly state types. You don't. I never have to say int I and int j. I can totally do that. In some cases where maybe maybe it's something, there are some cases where you have to explicitly give the compiler a little help. You might find that every now and then, but you won't. Just the way that you use it, it will only unify with one type. And sometimes that's any type. But or like, you'll see those in type signatures, alpha, beta, right? Like let's say, the type signature of map, right? It takes, it takes a function that takes A to B. It takes a list of A and gives you a list of B, right? So those are like generic, types. But most of the time, it'll unify correctly for you. You don't have to explicitly state any type.
Okay, I gotcha. Now, one of the cool features of OCaml, and other languages have this, but we're talking about OCaml, is this concept of an FFI, or a foreign function interface. Have you used those?
I haven't really, but I know that it makes talking to C really great.
So if I understand correctly, not only does it mean that you can call C, but you can also even make a library in OCaml and then expose it as C. So a C programmer would actually not even know that it was OCaml.
Yes, I've heard this before in IRC. There's also a great library called C types. I've never used it, but that's a thing, and people love doing it.
That's a thing, and people love doing it. I think what's cool about that, though, is it reminds me that OCaml isn't an island. It's not like, oh, you must be this way and you must live in our world. That's a recognition that you do have to interop at some point.
Yeah, no, it's very much about interoperability. Like the project I'm working on right now, so I write in OCaml, I compile to OCaml bytecode, then I take that bytecode and I use a program called JS of OCaml, which makes JavaScript, and then I run this JavaScript in the Node runtime. So I'm actually writing OCaml and I have an Electron app. So it's like kind of like a lot of song and dance, a lot of witchcraft, but it's a really nice development flow. And that's possible because people wrote these amazing bindings to Node.js and bindings to, Express and all these JavaScript libraries. So they did all the type work ahead of time for me to use this stuff. And that's really great. The OCaml community is really, really great. I can't stress that enough.
Mm-hmm. And you said this is called JS of OCaml?
Yes, I believe this came out of the Oxygen project, which had a couple of different really interesting things. It was a web project. They had like LWT, which is a cooperative threading library, which is really bread and butter in OCaml. It's used in pretty much everything. There's a lot of cool stuff that came out of that project. TyXML is another one that's pretty popular. So they have a lot of different frameworks that came out of that I think are potentially more popular than the rest of the project, but I don't really know.
And now, of course, the resulting JavaScript can't be really recognizable. I assume it looks just like magic, var 1, var 0. I mean, you don't really think about it like that. You're using JavaScript as its own runtime, aren't you? Like a virtual machine of its own. Well,
actually, Bloomberg made an OCaml to JavaScript tool, and that actually produces readable JavaScript. So it's possible that JS of OCaml might make that a thing. I don't know if it is a thing. I don't usually need it. I've never had, usually if there's a serious bug, I can kind of figure out what it is without needing to even read the JavaScript. But also because I'm familiar with web. But yeah, that's a feature in other tools.
So that's interesting. Now, did you know about this? Like you said, you were in Node and JavaScript. You were a web person. You didn't really feel it. You found OCaml, and then here you are back compiling it into JavaScript again.
Yeah, well, the Node ecosystem is amazing, and I definitely think a lot of functional communities can learn from JavaScript tools in the sense that people who write stuff in JavaScript tend to make things that are usable very quickly. They make great tools, even though, NPM, like the left pad, there was a lot of discussion. We have a package manager called OPAM, and it's really great. It's like the best package manager I've ever used. I will say if you're starting OCaml, OPAM, get really comfortable with it. It's fabulous. I brought this up for a reason. What was the reason? So left pad. So, after that whole, that guy took off that really important package and,
right. Then the important package disappeared and the world ended.
Yeah. And of course there was a discussion, like a little bit of, well, OPAM has been criticized a bit for being slow. There's like a review process and that sort of thing. And, it was kind of like, well, which is better? I mean, it's like you have a sea of garbage or like a tiny collection of treasures, right? It's like, which is better? Something like unmaintainable or something that's like overly maintained. I don't know what the right answer is, but it's interesting, like the difference in those communities and kind of making tools that sort of bridge those communities. Facebook just released Reason, which is so very hot. The syntax looks like JavaScript, but it is OCaml under the hood. And they even have tools that turn your OCaml project into a Reason project. So lots of cool stuff there, and I'm sure they will continue to dump talent into that. So, if you're listening to this and you're wondering, well, this is great, but this has nothing to do with my life or the things I build, definitely check out Reason. Those people are really smart.
Interesting. Now, backing up a little bit, to give people a little bit of context, you've got 1,213 packages in OPAM, the OCaml package manager. You've got over 250,000 in NPM. So that definitely gives you the sense of what's, do you want a highly curated and exclusive library where everything is guaranteed to work? Or do you want 15 copies of pad left, each one of which is possibly guaranteed to work,
I think these are unanswerable questions.
They are the great, as with all good religions, they are the great unanswerable questions.
It's like tabs,
I'm teasing a little bit. I'm going to get emails from angry Node people now.
Oh no, I love Node. Yeah, I love the ecosystem. I love, I love working and the Node.js bindings. It's OCaml, but it's still Node. It's still streams. It's still all that good stuff. It's still still all the stuff you want in Node. So
let's talk to me a little bit more about this reason for a second. I've read up a little bit about it. You can see it at facebook.github.io/reason. And by the way, if this is not proof that we've officially run out of things to call things, try Googling for Reason and finding the programming language called Reason and not literally everything else on the planet called Reason. But it's an interface to OCaml, right? It's a dialect kind of ML language. But is this another... What is this? Is this another OCaml?
That's a good question. I think a lot of it is to be determined. It's a new language, I think, is how it's being marketed, which is OCaml. So it's got the type system, it's got all that goodness, but the syntax is really just all it's changed, which a lot of people have been bemoaning a bit in the OCaml community. I mean, there are warts in OCaml syntax, but I wouldn't say that the syntax is the most painful part of OCaml. Like, far from it, in my opinion. Mm-hmm. But I do think it's a noble task to try to draw more people into OCaml and remove any boundaries to getting started. So if that's what the goal is, then I'm all for it.
Yeah, it's interesting. This may be a completely ignorant thing to say, and I hope that people who are listening will email me and say you're ignorant. Not you, me. But
also email me if I'm ignorant.
Yeah. I will forward all of my emails to you.
Great.
So, people like JavaScript, but JavaScript has some problems. So then someone goes and makes, CoffeeScript or even more dramatically TypeScript. And then you say, oh, well, you can have, JavaScript files are TypeScript, and also you can have TypeScript files. It seems like Reason is like a way of saying, well, here's another way of thinking about OCaml. And the OCaml build, we're going to replace that. OCaml build gets replaced with this thing called rebuild. So now you can build Reason files and OCaml files. So it seems like, to me, ignorantly, TypeScript is to JavaScript as Reason is to OCaml. It's almost like a wrapper, but it's compatible and it's friendly, and let's just see where this takes us.
Well, I think replacing OCaml build is very noble. The building OCaml is 100% the worst part of OCaml. No question. It's very difficult. And I'm constantly searching man pages, documentation. I mean, pretty much every project, I have to keep it open. It's something that's still really hard for me.
Really?
Yeah, for sure.
Why isn't it just install OCaml and type do it? And then it works.
It's confusing. How you set up your interface files, how you link with shared libraries, how you make libraries. Very complicated. There's a couple tools that make it better. The other thing that's difficult is there's the state of the build tools is extremely fragmented. There's 20 and there's no consensus on what's the best one. At least, in my limited view, I'm sure. I can already, I can feel the Twitter DMs, I can feel them coming. But yeah, there's, there's no real consensus. I would say that another tip to people who are just beginning, really look at UTOP, which is the top level interpreter. Just in the beginning.
That's UTOP?
Yeah, yes, UTOP. And do that, because it'll make your life a lot better. And then look at Oasis. Oasis is basically it generates cross-platform makefiles, I believe. And anyway, it's got a quick start functionality. If you just want to set up a project and just get it to work, I embarrassingly use makefiles. I mean, I'm sure I'm going to get, again, I can feel the DMs. I'm sure there's something better. But that's what I'm using right now to build my projects.
Interesting. I would have expected it just to be this like joy. Like I've heard everything about the programming language and the environment to be joyous. And then it's like, and then you got to build the thing. And it sounds like, eventually you hit, the abstraction isn't perfect anymore. And then reality hits in and building stuff is hard.
I'm sure there are people like, I remember at an OCaml meetup, some guy who had been doing DevOps for 30 years, I don't know, before the internet, before anybody, before anything.
On behalf of old people, thank you for that. That makes me feel really good about myself.
And he was like, well, I don't really know what you guys are expecting. This is not really that bad, blah, 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 blah. But inevitably, I just peripherally on the OCaml channel on Freenode, that's like the question of the day. There must be at least 5 questions a day about how to build OCaml. So
really?
Yeah.
Wow.
So I think it's so that's why I'm also excited for Reason is I just want easier ways to do that. So that doesn't have me combing documentation, but I think one day you just wake up and all the things and then this is no longer a problem. So once I get there, but that really is the only ugly part for me. Everything else is fabulous. It's just that really.
Very cool.
Yeah.
So are you, what do you run it on? I'm looking on their website and I see all kinds of Linux flavors mentioned. I see, Mac mentioned, but I also see, Windows gets kind of and also Windows, bit of a comment, and there's different ports and kind of, it doesn't seem like it's like super epic on Windows. What's the story and what's the best operating system to try this on?
I don't know. Mac worked really great for me, OS X. But I use Fedora, so I'm a Linux user. But anything Unix is going to be great. Windows, I know the situation is a bit precarious. I'm not really sure. I've never tried to run OCaml on Windows, so I don't know the answer.
Well, I am, as we are sitting here talking, installing it using Ubuntu on Windows to see if that will work. So I'll have Ubuntu running on Windows and I'll see if I can get something to go on.
Oh, good.
It's very interesting, though. There seem to be also some different ways to do it. It looks like it does run. Yeah, so I just ran opam config env.
Great.
And where are some places I would go and learn about this? What's some good code examples to play with?
Yeah, that's great. So I've got some stuff on my GitHub. Let's see. I've got some code. Woo! I think there's a repository on my GitHub called example OCaml, example-OCaml. So that's
okay.
GitHub.
And where would we find your GitHub?
Yeah, so it's github.com/wiredsister. That's wired as in cables, and then sister as in your sister. And if you click example OCaml, so that's /example-OCaml, you get a repository that me and this other guy, FX Factorial, used to do presentations. If you click the examples directory, maybe click the sumodds.ml file. Here's some functions for just summing odds. And this is kind of interesting because you can see in the bottom, I have an imperative solution. So that might be, remember we were talking about mutability. Yeah. So here you see that ref 0 as the counter. Right. And then that bang counter is sort of dereferencing that type of idea.
So I would say that OCaml is probably, of all the languages, the one that is least likely to be explained syntactically on a podcast.
Okay.
But you know what I mean?
Totally valid.
You know what I mean? I'm like, but if list.fold right. And then I'm like, oh, that's an arrowy thingy. What do we call that? I'm sure that there's like a, what do you call it? Hash rocket or super bang or something?
I'm pretty primitive. I just say arrow. There's no other, arrows. There's a left arrow for anyway, that doesn't matter.
I know. But I'm going to put a link to this though in the show notes so then people can can see that. So, and then once I've got this down, like, do I just say OCaml in the name of the file that it's in, or how do you run these things? Yeah,
so it's just, you can use OCaml C or OCaml opt. So that's the native code is opt, and then the bytecode is C. So yeah, just, let's see. OCaml C, and then just your program, and it should go, I think, just as standard out, but let's see. But the other thing you can do, which I think is better for people just starting, is utop, and then paste in utop, and then you use 2 semicolons and hit enter, and then it'll evaluate whatever you drop in. And that's kind of, I don't know, I prefer read eval print loops for just beginning. Okay, so utop is the REPL, and that's where I spend my time. Yeah, and you can just OCaml install that. Okay, very cool. And actually, I'm going to, just while we're sitting here for a second, I just say OCaml install utop. It says, just make sure that you specify OPAM init. OPAM init, yes, sir. Okay. It gives you great help. It really does. Well, yeah, it seems to be very, very clear on what it's doing, and it tells me it's giving me nice instructions and stuff, and then I'm off and doing it. Cool. Well, this has been super educational, and we can learn about this, of course, at ocaml.org. And then on your GitHub name is Wired Sister, and I'm going to include your example OCaml stuff up there. And then the other thing was JS_of_OCaml, or JS of OCaml. And then the other thing we talked about was Reason from Facebook, which sounds super interesting. And last but not least, if you're using an Emacs or Vim or whatever your setup is, look into Merlin, which is a plugin that'll help you get a lot of really cool type checking stuff. And that has made my life incredibly easy. So that's just one other tool I would throw out there, is Merlin. Okay, cool. I will send all of that in the show notes, and I really appreciate your time. Yeah, absolutely. Take everything I say with a grain of salt. I'm still learning, but OCaml.org has great stuff. Please feel free to ask people on IRC. They're so nice. They're not like those, those stereotypical mean functional programmers. They're very nice. I don't know what the stereotype would be. Maybe like ranger hats and like, those strappy sandals or something. I don't know, but they're not that. They're very nice. Very cool. Well, thank you so much, Gina Marie Maini, for your time today. Yeah, no problem. This has been another episode of Hansel Minutes, and we'll see you again next week.